Hello classmate! In this class, we will learn the principle of triode amplifier. First, let's listen to a piece of music. We just listened to this wonderful music. The sound is amplified on the original basis. As the name suggests, an amplifier is a device that can amplify. It is widely used in communication, audio, broadcasting, and other fields. The most basic amplifier is an amplifier circuit composed of a triode. The triode is the most important device in electronic circuits. Its main function is to amplify and switch. So how does a triode achieve amplification? First, let's learn about the generation of the triode. In 1906, American De Forest invented the vacuum triode, which opened the door to human electroacoustic technology, which ushered in a new era of audio technology. This is due to the improvement of amplifier performance. So the most basic amplifying circuit. How does a transistor amplifier circuit work? The most basic function of a transistor is amplification. It can turn weak electrical signals into an electric signal of a certain intensity. Of course, this conversion also follows the law of conservation of energy. It just converts the energy of the power supply into signal energy. Here we will take the MPN triode, common emitter amplifier circuit, as an example to explain the principle of triode. Current amplification, as shown in the figure, is an MPN triode amplifier circuit. In order to make the triode have amplification effect, the manufacturing process requirements are considered, such as high doping concentration in the emitter region, and the base region is very thin, much lower than that of emitter and collector regions. The collector region has the largest area, which is convenient for collecting electrons. Now let's learn the current amplification process of the triode. First, the process of electrons diffusing from emitter to regions. The power supply VBB passes through the resistor RB, applied to the emitter junction, making the emitted region junction forward biased. At this time, electrons are emitted from the emitter to the base region. The free electrons in the emitter region go over the emitter junction and enter the base region. The negative pole of power supply VCC replenishes electrons to the region, forming the emitter current IE. The direction of current IE is opposite to the electrons' movement. Meanwhile, the majority carriers in the base region host diffuse to the emitter region. However, the majority carrier concentration in the base region is far lower than the concentration of carriers in the emitter region, so the resulting current is very small. This current can be ignored. Therefore, it can be considered that the emission of electrons from the emitter to the G region is the main current. Next, we will learn about the process of electron diffusion and recombination. After electrons from the emitter region enter the base region, a small number of electrons recombine with the holes in the base region, pull electrons from the positive pole of VBB, replenishing the recombined holes, forming the IB current. At this time, the ratio of the diffusion stream of electrons to the recombination current determines the amplification ability of the triode. Finally, it is the process of collecting electrons in the collector region. Due to the large reverse voltage applied to the collector junction, the electric field force generated by the reverse voltage will prevent electrons from diffusing into the base region. After the electrons from the emitter enter the base region, a small number of electrons will recombine with holes in the base region. Most of the electrons cross the emitter junction and enter the collector region, and the collector region collects electrons. Electrons flow to the positive pole of the power supply, forming an IC current. The principle of triode amplification is simply: the working premise of a triode is that the forward voltage is applied to the emitter junction and the reverse voltage on the collector junction. The current amplification process. The process of current amplification involves electrons diffuse and combine at the boundary of base region. Holes are replenished by the external power supply. Electrons are collected by the collector, changing the base current. The collector current can be changed. It can be verified through experiments. The base current IB and the collector current IC have such a relationship. IC equals beta times IB, where beta is the amplification coefficient of the triode, which is also an important parameter of the triode. That is to say, when a small current is applied to the base of the triode, a current that is beta times the injected current can be obtained at the collector, which is the collector current. The emitter current. The collector current varies with the change of the base current, and a small change in the base current can cause a large change in the collector current. This is the amplification effect of the triode. In this class, we learned the principle of current amplification of triode. The triode can amplify current, whose prerequisite is that the emitter junction is forward biased and in the collector junction is reverse biased. The amplifying circuit. The essence of amplification is energy control and conversion. On the surface, it increases the amplitude of the signal, but the essence of amplification is energy conversion. It converts the energy of the DC power supply into alternating current energy with the same input signal frequency, and into alternating current and increased amplitude to obtain more into an AC output with the same frequency as the input signal on the load. Is the basis for learning the application circuit of transistor. We need to firmly grasp it. A high-rise building starts from the ground. Only by laying a solid foundation can we build the skyscrapers of knowledge. Please think about it. A triode can amplify current and can also be used as an electronic switch. So what are the prerequisites for a triode to be an electronic switch? What are the prerequisites?